we quickly summarize our past few years of experience in applying AI, including machine learning and deep learning, to the industry, especially manufacturing industry and the elderly care industry. So let's first talk about the important steps in implementing an AI project. The first thing you need is a sensor to uh, perceive your environment to acquire data. And then you have to transfer the data to your server for further analysis, either through internet or through other wireless transformation like Bluetooth. And then after that, we perform three things together. First, we will build a data dashboard to visually explore our data. And secondly, we will apply the traditional programming approach to, to code of what we are going to look for the data. And thirdly is the latest machine learning approach where we give the machine learning model the data and the answer and let the computer learn the rules. Actually, these three steps are done in a cycled way. So they depending on each other and they interact with each other. Here's some examples of the AI presentation we did in the company. AI competition. As you can see, okay, the categories of this competition, including both, including all the composing elements we mentioned before, sensor perception, data transfer, and data dashboard, and finally AI. And if you look at the topics, first, of course, is the predictive maintenance, and secondly is the virtual metrology, collecting the process parameters and trying to predict the quality of the product, and then the management of the inventory and the dashboard, the dashboard to visualize the process data. Also, you can see some projects they use AI to do a regression or do classification. Okay, so let's summarize some ideas we got in apply AI in real world. So the first thing we want to talk is the human in the loop approach. So basically because the AI just learn a mapping function from the input data to the true answer. So basically you can see AI is still a statistic summary. Okay, so it's unlike the human. Our human reasoning, we have common sense. Also, we know the casualty of the logical casualty between the cause and the effect. But AI just simply learn a mapping from the data. So the quality of this mapping really depending on the quality of your training data. And especially in manufacturing, usually we are not able to collect the complete data for predictive maintenance or for virtual metrology. So sometimes the AI model we built is not that strong enough. That's why we still rely on humans, okay, together with the AI to solve the problem. Okay, and because AI only learn the statistic summary from the input data, the AI cannot differentiate the unseen data or data should not appear. Okay, is and unlike AI, human knows the logic reasoning. Okay, and human have common sense, so we human expert can explain the causality of why this happens. So in real world or practice, usually we took the human in the loop approach to combine human with AI. And the second approach we adopt in real world AI is the ensemble approach. Just like because each machine learning model just try to summarize your data from one perspective. So usually we will build 3 or 4 machine learning model to see if the conclusion from all these machine learning model are consistent, then we take the conclusion. But if the conclusion from this machine learning model are not consistent, usually we will present the result to the human and ask the human engineer for the final answer. And the third one we want to talk about is try to solve simple and small portion of your problem, your real world problem first, because the real world problem usually is complicated. Okay, so if you build a machine learning model, you took some data, you thought, okay, your model, the loss function will soon goes down and your model converge. But in many cases, if your data is not consistent, your problem is complicated, you will get your loss function will not converge, and the confusion matrix is very bad. Sometimes you get like 50% of accuracy, which is it's just like flip a coin. Okay, you are not gaining any advantage from your AI model. So sometimes we will ask the students or we will ask the cooperative company, just try to simplify the problem. Try to make the data within group be as consistent as possible, and try to make the data between groups as far as different as possible, so we can solve the problem easily. Here's the example. As you can see, the data within each group is consistent, and data between groups are apparently different. In this way, we can easily train a cycle GAN to convert from here top to bottom, or from bottom to top. And finally, the fourth one is, if you want to apply AI in real world, you have to be prepared for multidisciplinary cross-domain communication. Usually, based in our experience, the time we spend on building the AI model usually is less than 5%. 95% of the time we spend is communicate with the domain experts to discuss our data, to clean our data, to find features from our data. Okay, so after talking about this real-world practice, let's go back to see what the AI learns. Just as we mentioned earlier, AI learns a mapping function from your input data. If you tell the computer, if my input is X, then my answer is Y, then AI will try to learn this mapping function. So if your mapping function is a statistic function, or is a mathematical function like a random forest or SVM, then this we call this approach the machine learning models. Okay, the advantage of using statistic model over machine learning models is because we have less number of parameters, so that our model is easier to explain. But then the limitation is also this because the number of parameters is limited, so that this we can only handle linear function. Usually we cannot model complicated dynamic function. On the other hand, if we use a deep neural network as the mapping function, then we have a much larger number of parameters, sometimes millions or hundreds of millions parameters. So we can easily find a nonlinear complicated mapping between the x and y. But then the drawback is it's very difficult to explain this model. So there are always pros and cons of these two approaches. And for this neural network, we have three ways to train this neural network. The first one is we label our data. We just tell what is x and what is y. So for example, if we tell the computer this is good and this is Parkinson's disease, then the neural network will learn. But the problem is you have to label your data. Okay, so for many applications like object detection or key point recognition, you have to do a very tedious labeling work, which is very time consuming. So for internet companies like Facebook and Google, they automatically receive millions of images or videos every day. It's impossible to manually label this data. So we have this second approach called self-supervised learning. We just feed the neural network the data, and the neural network will automatically learn the representing features. For example, here the neural network automatically learn the features represent class 1 and class 2 images. And for certain applications that you cannot teach, like how to play video game, how to play chess, or how to play a basketball or baseball, you cannot just show people the video or images. People have to interact with the environment and learn. So if they fail, they learn, okay, not to do this next time. If they succeed, then they will learn these lessons. So we have to put AI in a simulation environment to learn, okay, to let the AI interact with the environment to learn. This type of learning is called reinforcement learning. And with this concept, let me show you how to implement the deep learning. So first we use the Python programming language. And Python, we usually use two Python platforms. One is Anaconda, which run Python in your own computer. Another is Google Colab, which lets you run Python in the web browser. And then to build a neural network, we use the PyTorch framework. Of course, the neural network, we know it must be run on GPU to speed up its matrix manipulation. And usually, these big companies already trained the neural network for computer vision. So we use this pre-trained neural network for many computer vision tasks. And usually we use the model from Torch Vision and the Detectron 2. And for reinforcement learning, we need to build a simulation environment where here we use Unity and a package from Unity called ML Agent. And once you train and develop these neural networks, sometimes you cannot put a GPU PC to the field, you have to deploy your neural network on a smaller edge computing device like NVIDIA Xavier or Intel OpenCV AI Toolkit. But the neural network you run in GPU usually runs very slow on this edge computing device. So usually you have to convert to their specific format. For example, in NVIDIA JSON series, you have to convert your neural network to TensorRT. And for Intel's, you have to convert it to OpenVINO. Okay, so finally, let's summarize the AI project we are doing. As we said earlier, we are not developing new AI model. Instead, our AI project in real world, in industry, usually we are doing integration work. We just use the existing model and try to apply it to real industry. So the first type of AI project we are doing is integration of the machine learning result with the domain knowledge. So if our project, the input is the data who collect, is the sensor who collect data, not the image. If our input is data, numerical data from sensor, then usually, as we mentioned earlier, we will use machine learning model because the result we can explain. So we use the machine learning model to find the important features in the data or important instance in the data. And then we have to do a heavy communication with domain experts to explain why we get this machine learning results. Okay, so first, the first type of AI project we are doing is if we get numerical data from sensor, then usually we use machine learning. And the second type of AI project we are doing is if our input is images, okay, because images still is the easiest and the non-intrusive way to get data. You don't need to attach any sensor, and you can use your mobile phone, or you can use webcam, or even the surveillance camera already give you the image. And then in this case, we will use some pre-trained image understanding neural network to extract the joints to recognize the actions so that we can get time series data or get categorical time series data. Once we have this numerical data or categorical data, then we apply machine learning and try to get the result and then spend a lot of time meet with domain experts to explain the result. Okay, finally, if you want to see some interesting computer vision task, the deep learning neural networks for some computer vision task, you might go to my GitHub. Okay, because I have in other videos I have already explained this, so I will skip. Okay, so basically that summarizes our past few years experience in applied AI in industry. Thank you.